Right, so drawing a Wheatstone bridge diagram, you've got 4 resistors, one is a variable. If at this point here, where the Wheatstone bridge is balanced, that means that this would be whatever value resistance would balance the Wheatstone bridge. So we're going to assume that resistance is, say, 2 ohms. If we make the resistance bigger, say 2.1, 2.2, it's going to go in a graph like that. If we make resistance smaller, it's going to go in a graph like that. Notice this whole thing is, in fact, a curve. It's not a straight line. So this is a curve going through the origin. It's a curve. Okay, now I've just drawn that scaly, but hey. So it's going to be a curve going through the origin. Now, what that means is, for large changes in resistance, from going one way or the other, it's not a linear relationship. Okay, you can't just say that the more you unbalance the Wheatstone bridge, the more the voltmeter, the more the voltmeter goes up. It's not about that. It's about saying that, okay, that as you outbalance the Wheatstone bridge, as you change the value of resistor, the variable resistor R, this variable resistor here, that for large deviations from the centre equilibrium position, which is this here, you're going to get a curve. So what we do is we say, right, that's not going to work. We can't say there's a linear relationship between what value the voltmeter is and how much out of balance the resistor is. So we have to say, okay, where is it a linear relationship? Where can we say it is linear? And to do that, we take a very, very small area round about here. So let's take this little bit in here and let's make that bigger. Let's make that whole bit of graph bigger. So let's make that whole bit of graph bigger, and you end up with a graph that looks like this. Here's V, here's R that we had before, and the curve comes up, it's coming along, and it's going like that. That's that little tiny bit in the middle. This is this made bigger. Okay? At that bit right in the centre, it is a straight line. It's pretty much a straight line. You've taken a bit of graph, you've made it bigger, it's pretty much a straight line. So essentially what we're saying is that for large changes in R, the voltage, the voltmeter in the middle, the reading on that is not nice and linear, but for very small changes in R, the amount of out of balance it goes is linear. So, the bit in your notes that says that for small changes in the value of one of the resistors in a balanced Wheatstone bridge, the unbalanced voltage across the bridge varies directly as the change in resistance. But the most important part is only for small changes. If you make a huge change, it's not going to be a direct relationship. Okay? So, you've taken this graph, you've made it bigger, and the note we want to say is that for small changes, right? So, for small changes, now can we copy this down? For small changes,
But you copy the diagram?
Yep, I'll maybe rearrange them a bit more better for you. I'll rearrange them a bit better for you.
What's the heading?
The heading can be
Unbalanced.
Unbalanced Wheatstone bridge, just that is at the top. Unbalanced Wheatstone bridge.
Keep it up.
Okay, so copy the diagram down to show that that's what it looks like. Copy the graph down to show it's a big curve. Then mark the little box and make that bigger to show that that's what you're going to get. And I'll select this bit here so I can move it about. Right, so make that bit bigger, move it down here. And the note we're going to write down is for small changes in the value of one of the resistors, what we're going to say is that the voltage varies directly with resistance. The voltage varies directly with resistance. Now this is from a balanced Wheatstone bridge becoming unbalanced. Right? So you start off with a balanced Wheatstone bridge. So let's write down also that the Wheatstone bridge starts balanced. Okay, so you start off with a balanced Wheatstone bridge, And for very small changes, now this is something that comes up time and time again. I've seen it in exams. For small changes, they give you huge changes and say, will that affect it? Well, was that a linear relationship? Well, no, it's not. Only for small changes does that mean it's a linear relationship. And you can see that if R goes up, V goes up. R goes down, V goes down.
Do we just cover them in